Okay, final step here, which is simulation. Click back over here to the mold layout tab. You can see over here on the right we got mold simulation. Now you may have noticed when we were in the core and cavity section earlier you could do part fill analysis. Well, part fill analysis is cool, but it doesn't give you really complete results. It doesn't take into account the shape of your gate, the shape of your runners, sprue, anything. All it looks at is just strictly, it gives you a one point for your gate and then just the part shape. Now you can use it to get some quick information and just a general rough idea of whether or not your part is going to perform the way you want. But I do run it a lot before I got all the trouble of making the whole mold. But this one is a much better simulation. Now it is worth noting that this is a very stripped down version of Autodesk Simulation MoldFlow that's built into Inventor Pro. It's not going to give you all of the same information, and it's certainly not going to give you the same information density that you'll get out of Sim MoldFlow. But it also doesn't cost $80,000, so there's certain trade-offs that you have to make there. Start off with mold process settings. We'll click on that, and I'm going to go ahead and click on the Suggest tab because I can throw numbers in here all day long, but Inventor will figure out a good starting baseline to work from for determining your process settings. And we can pick from 3 different types of finish here. Now, being a gear, this is probably not a cosmetic part, since we didn't try to make it fancy. This is probably just going to be an internal piece. So low gloss is going to be okay for the surface finish. And I'm going to go ahead and click Start here. And I'm going to actually pause the video once the simulation is running, because you don't want to sit here and wait. So pause. Alright, and we're back. That took about 3 or 4 minutes in the end. The actual analysis was quick, but everything leading up to it took some time. So it automatically brings up this window, which is kind of a summary of the results. And using this particular material that we used, which is a 6/6 nylon, 33% glass fill, it recommends that we start off with a mold temperature of 180 degrees, a melt temperature of 556 degrees, and yes, this is all in Fahrenheit. I still don't think in metric. For me, degrees are always going to be Fahrenheit. Injection time will be 0.75 seconds. Now you notice over here it shows us the little 7 for the recycling, and that's of course other plastics, which your recycling centers all hate. It says environmental impact is only 3 out of 5, so less energy to mold this than some. And you click over here to the General tab, and it says, okay, the imported model is thick and chunky and appropriate for 3D analysis. Analysis resolution is just going to be default. We're not going to do a real high density analysis here. The max machine injection pressure that this is going to need is going to be somewhere around 26,107 for the injection, or for the barrel pressure, or no, the injection pressure, sorry. So we'll go ahead and hit OK. And now when we click back on mold process settings, you'll see that the recommended default, or the recommended settings, have been carried over in here. So we'll hit OK again. We'll hit mold, actually before we do that, and check on mold shrinkage here. Now, of course, shrinkage is really an extremely esoteric art. Manufacturers don't like to publish real accurate shrinkage numbers. They'll give you kind of a range because they don't want you to hold them to it if there's a slight formulation change or anything. So in this case, for this Aculon, the range is 0.1% to 1.1% shrinkage, and Inventor kind of takes a median on that of 0.6%. If we uncheck isotropic here, then we can specify our own shrinkage in all 3 dimensions. And Inventor again can, can give us a estimated, a suggested shrinkage to use, and based on end of fill pressure or absolute pressure or whatever. But I'm gonna just stick with the default isotropic 0.6%. So, oh, no, I wanted to cancel that and not edit it. So, okay, mold fill analysis. Go ahead and hit that, and we're going to hit start again. And then again, I'm going to pause because this will take a few minutes. It won't take very long, but I've got a i7 4770K and 16 gigs of RAM, and this will still take a good solid couple of minutes to run. So, pause. Alright, and we're back. And you can see here, our part can be filled easily, but part quality may be unacceptable. And we're going to take a look at the results here in a minute and see where we can expect it to go wrong. But you can see there's quite a lot of information here about the process. Shot size, cavity volume, etc., clamping force, and you can mess around with that a little bit. Our cycle time, this is based on a mold open time of 5 seconds. Our fill should be 0.77 seconds. Estimated pack and fill time, or pack and hold time, 12.72 seconds. And if we have 5 seconds open for ejection, then total of 18.49 seconds. So go ahead and close that. And we're going to take a look at results. You see over here in the browser bar. I'm going to look at the fill results. First thing, we're going to look at fill time. You can see that we've got you can see the runner system, the cold well, or which we never did go back and adjust the diameter on that, did we? We've got our sprue and our part. You can see over here a little graph for the fill time. Now over here in tools, we'll hit animate results, and this will give us a neat little animated display of the filling process. And it takes it a minute to calculate this. This is really some pretty heavy duty calculations it's having to do here. So we'll set that on a loop. And view is a little bit dark here, so we'll go over to the view tab, and we need to turn off the shadows. I've got ambient shadows on, and there we go. Now that makes everything look a little bit brighter. And you can see this is the path by which the plastic is going to flow through this mold. You can see right here, it looks like that's where we're going to have a weld line. And in fact, you can even overlay the weld lines there, and yeah, right, exactly there. You can see where it's going to predict that we have weld lines, where the melt fronts are going to come together. Confidence of fill, high confidence of filling the whole part. Quality prediction though, yeah, and that's because we've got a very chunky part here with a lot of glass fill, and so yeah, it's going to have a little bit of a rough time getting us a good quality out here. And we can adjust the material to have something with a higher melt flow rate, or well, probably not glass filled nylon ideally, but we can adjust that. But this is a good little view here to see what we're going to look at. So there you go. We have now spent almost exactly 1 hour and gone from digital prototyping all the way through mold design and even on into some very basic MoldFlow analysis simulation, all in just barely an hour. Thanks for watching, and have a good rest of your day.